So in 2.4.2, we have a previous problem. We had x values and probabilities. You might have forgotten that x equals 4 was one of the values because we had to find that missing probability in a previous step. And from a previous problem, we found the expected value of x is 2.48. Now, to find the variance, there are two different ways you can do it. I'm going to show you the first way, then I'll show you the second way. So the first way is what I did before in the lecture. It's you take the sum and you take each x value minus the mean and times it by its probability. Oh, I think I forgot something. That would need to be squared. Because if we don't square it, then our positives and negatives cancel out. Okay, so let's come over here to, I made this nice little table, and let's find what each x value minus the mean times the probability would be. So we'll have 0 minus 2.48 times the probability of 0.08. And 1 minus 2.48, I keep forgetting that squared, times its probability of 0.11. And 2 minus 2.48 squared times its probability of 0.27. So I'm going to keep doing that, and then I'm going to add them all up and find a total. So let me pause it while I try that. First though, just so you can compare, so this first value should be 0.4920. Let's see, 2.48 squared. The next one should be 0.2409, etc. So I'm going to just stick it all in my calculator now, which when I add all of them up gives me 1.3696. So my variance of x equals 1.3696. So my standard deviation would just be the square root of that. Now, depending on how much you rounded, you might be slightly off, but it should be fairly close. So we found the variance and standard deviation. There's another way you can do it that is a little bit faster if you are doing things like this by hand. So the variance of x, you can do it that way, or you could find the expected value of x squared minus the expected value of x. Now, I don't like teaching this method as much because it is faster, but this first method teaches you what does the variance really mean. It is each value minus the mean squared, oh, I gotta write that square, times its probability. And that's really what the variance is supposed to be doing. And so I like that one conceptually. This next method is a little bit easier though. So the expected value of x squared, how would you find the expected value of x squared? You would have to sum up each x value squared times its probability. So if you want an expected value of x, you just sum up each x value times the probability. So if you want an expected value of x squared, you just add up each x value squared times its probability. Okay, so in our case, it would be 0 squared times its probability of 0.08. Plus my next one, which is 1 squared times its probability of 0.11. Plus 2 squared times its probability of 0.27. Plus 3 squared times 0.33. Plus 4 squared times 0.21. Put all this into your calculator. I'm just going to look at the key to save time here. So and when I put all that in my calculator, I get 7.52. So that's the expected value of x squared. So now to find our variance, which again, the variance is expected value of x squared minus the expected value of x. So this will be 7.52 minus the expected value squared. So 2.48 squared. I'll put that in my calculator. 7.52 minus 2.48 squared gives me 1.3696. So that's my variance. So again, you can do it two different ways. This variance formula up here is what they first came up with because that's what variance actually means. That's what variance is supposed to be. But then they realized this trick, they went through the mathematical proofs and showed that it always worked. And they realized this trick is a lot easier to put in your calculator, especially if you have to do something more complicated than 5 values. So this one is easier to put in your calculator. This one though actually shows you what variance is supposed to be.